I'm here to introduce our new touch sensing solution enabled by our latest programmable system on chip and PSoC creator software. The new touch sensing solution is based on PSoC 3 and PSoC 5 products.
Now, let me use 5 minutes to go over a presentation that introduces PSoC plus CapSense solution built in PSoC creator software. So, as you can see, not only we integrated the traditional PowerPoint-based presentation, on the left-hand side, we actually integrated 2 example projects, CapSense Motor Control and CapSense SmartSense, into the same presentation. The first slide shows an overview of our PSoC plus CapSense solution. PSoC 3 and 5 CapSense support everything in our current CapSense solution, including buttons, linear sliders, radial sliders, matrix buttons, and touchpads. And the CapSense here in PSoC 3 and 5 used the same algorithm in PSoC 1. And because of the precision analog and flexible digital resource and much better horsepower, PSoC 3 actually delivers the true system integration. For example, on the left-hand side, you can see we're integrating the LCD direct drive, CAN user interface bus, power management, and precision analog, audio streaming, etc. Cypress has the broadest and most advanced touch sensing portfolio. The highest end PSoC 3 and 5 is a system solution due to its system resource and CPU horsepower, and CapSense is more of an embedded solution. CapSense Plus can be a system solution, but most of the time it's a peripheral solution where its main function is user interface, but it can integrate parts of the system function to offload from main CPU. CapSense and CapSense Express is a user interface solution that is a drop-in replacement for buttons and sliders. The difference is CapSense Express costs less and is a fixed function discrete. So what exactly is SmartSense auto-tuning? Well, as we all know, any last-minute change to the industrial and consumer designs and the marketing requirements will require a complete retune of your CapSense solution. And SmartSense automatically sets and optimizes the tuning parameters. The time-consuming and sometimes cumbersome tuning is now reduced to an automated process that continuously monitors and optimizes based on the environmental condition. With engineering resource always limited, SmartSense allows a platform architecture approach that can be leveraged across multiple products and industrial designs. So, what outstanding value can PSoC 3 bring to our embedded design? Well, on the left-hand side, you can see it's a typical implementation of a customer system, a user interface board that has a dedicated CapSense IC, and then a main control board where a main CPU controls the whole system. And these 2 boards are connected with a dirt cheap ribbon cable. On the right-hand side is our PSoC 3 solution. PSoC 3 integrated the CapSense IC and the main CPU into a single chip, and when we drive the CapSense buttons and sliders over a ribbon cable. Since we have SmartSense auto-tuning, customer does not need any code change or debugging while plugging the cable. And our CapSense solution offers high immunity to noise, which guarantees signal-to-noise ratio while driving out over the cable. These 2 elements enable us to drive CapSense over a cable. The CapSense in PSoC 3 is mainly built on the hardware UDB, Universal Digital Block, that is CPLD based. So it's mainly hardware based, which translates into 0 CPU horsepower while CapSense scanning. This is a significant difference from the solutions that already exist in the market. The CapSense over cable and CPU horsepower saving offers the ultimate integration into customer solution. So where should we get started for a PSoC 3 CapSense design? Well, we have a CapSense application work page, and the website is www.cypress.com/go/PSoC plus CapSense. On the web page, you can find links to the development kit that you will need to start a PSoC 3 CapSense design. And on the web page, we also have collaterals, including component datasheet, which is integrated in PSoC creator software as well, and CapSense application note, design guide, video training, etc. Now, let's take a look at the demo project that we will show in 1 minute. Here I'm going to select the top design file under project CapSense_SmartSense. So there are three components in this design. One is the CapSense CSD, which drive the CapSense button, and that include 5 CapSense buttons and 1 10-element sliders. As you can see, if I double-click the CapSense component, I can see the wedges configuration, which include 5 buttons right here. And this volume control is a linear slider, which is 10 elements. And you can see all kind of wedges, including radio sliders, matrix buttons, touchpads, proximity sensing, and very generic CapSense solution. Inside the CapSense component, if I right-click on the icon and then select Launch Tuner, there's actually a GUI that will help us to observe the dynamic behavior of each of the CapSense buttons. We will show this demo in real time for the GUI later on. So this I2C interface is used to feed back the data from the GUI to display on our PC. And this LED control actually update the LED status based on the button and the slider activity.
The hardware I'm using here is CY80C Kit-030 PSoC 3 development kit. This kit allows you to develop precision analog and low-power designs using PSoC 3. Now, the extension board here allows you to develop your own expansion board and plug it in from here and then build up your own ecosystem. The USB port here is used to program and power the board, and the Mini PROC 3 programmer here serves as an I2C bridge to read the CapSense data back to the PC. Now we have the GUI running here. And then I'm going to push the CapSense elements on the slider module board. As you can see, the GUI is reflecting the behavior of my finger on these CapSense elements dynamically. And here I selected button number 1 so that I can specifically observe all the parameters and like the performance spec of this element. So you can see when my finger is on button 1, and then on the right side you can see the SNR rate and the finger threshold, noise threshold, etc. And the reason all those parameters on the right side are all grayed out is because the smart sensing algorithm is enabled in this example project. So over 10 parameters here are automatically optimized so that we can achieve the best performance. In the graphing tab, we can also observe the data in a more dynamically way. And I can select any of the elements I want to observe. So I'm going back to select button number 1 again. So before my finger is on this button and all the data here you can see is like white noise. And when I put my button here, you can see the data and the baseline gets automatically adjusted. Now I'm releasing the finger. And then when I push it back on, the data is changing in real time. So what if I want to observe the data and archive the data for future analysis? On the logging tab, we can see all the raw data are archived in this debugging tab, and then you can also export all the data to anywhere you want to your personal PC. What makes this demo even more fun is now that I'm going to add a ribbon cable between the CapSense board and the main control board. And without any changes in the firmware and debugging, the CapSense element can still achieve 85 SNR performance spec. Now, the ribbon cable here added around 15 picofarad parasitic capacitance in the system. Now, let's see how did PSoC 3 automatically optimized all those parameters. So I'm using the same -030 board, the same silicon, and I did not reprogram the board again. The only difference I made here is to add this ribbon cable, which is 18 centimeters long. And then let's see the CapSense performance after we add the ribbon cable without changing any firmware and debugging development process. On the screen here, you can see this is the GUI is running, and I'm pressing my finger on the slider and then pushing the button as well. So we added the ribbon cable And then let's see the SNR rate on button number 1. As you can see on the screen on the right side, the SNR rate achieved at the same level as the demo without the cable. It's 85. This is all thanks to the smart sensing algorithm in PSoC 3 that auto-tune over 10 parameters without any additional engineering effort. The true value of this solution is system BOM and NRE reduction. The smart sense algorithm and high immunity to noise ensures CapSense performance over cable. And that the fact that zero CPU horsepower used during CapSense scanning offloads the main central control CPU to perform other system tasks.